right, that's looking good. Yeah, so let's get started. I'm Stuart Fox. I'm here with Ryan Adams from Silfab, and I'll do a quick introduction, then hand it over to Ryan, and he'll update you on what's happening at Silfab. Ryan, let's go to the beginning slide. Get an overview of Silfab for 2024 and beyond. And then we'll go to the next startup slide. Of course, as with all of our webinars, we're uploading data sheets now to the handout section of the webinar platform. You'll see them over there. Please use the chat section for questions as we go. Probably just answer them at the end. Yeah, that's the intention, but feel free to drop them in there and we'll get to them. And then, of course, as always, we'll be recording this, and you can relive the beauty of this webinar later on at your leisure. So let's go to the next slide. Yeah, so I introduce Green Tech Renewables. Green Tech Renewables is dedicated to innovating solutions for our customers that will drive feasibility and profit while offering the highest level of customer service, professionalism, and integrity. This is an update to our slides, so I wanted to read through it. But yeah, so we're basically a local distributor made up of 100 locations across the US. We're, of course, a full service distributor with products like Silfab, but then you can also get anything else to build your project while we're supplying the Silfab modules. So yeah, Green Tech's built on service, integrity, and reliability. And then the next slide, this is my part of Green Tech, design services. So as a Green Tech customer, anybody is eligible for using our in-house design services. My team is a service team within Green Tech. So we can design any kind of project you have for you. Our specialty, of course, is permitting documentation, permitting submittals. We have a platform that's available 24/7, 365, and you can manage your design projects and start new ones anywhere in North America anytime. And of course, we support any kind of project pretty much anywhere in the US, carports, storage, little projects, neighborhood projects, and utility scale projects. So yeah, so next time you want support for permitting, or like you have a new Silfab project after this webinar, bring it to us and we'll put together a permit set for you. But yeah, thanks. Let's go to the next one. So with that, we will kick off the Silfab part of this, and I'll hand it off to Ryan. Thanks, Ryan. And I'm gonna drop into the background here, but I'll keep an eye on questions too as they come in.
Perfect. Appreciate it. And appreciate everyone's time coming forth. Obviously, everyone's busy. It's peak solar season, so I'll try to get as much information to you as I can here, and certainly look forward to the questions afterwards as well. So I'm the Director of Business Development at Silfab. I've been here for about 6 years, but in solar for 15, from utility scale development to distribution to the inverter side of things. I have enjoyed most of my time, of course, and many of you as well. I'm sure I've met 125 people on today, and hopefully some of you have known me. If not, I hope I can illuminate some more details on the Silfab side of things. So we're going to start with a poll to kind of get a sense of, of the people that are on today. How many are familiar with Silfab? How many of you heard a little bit, don't know anything, use it every day? So we get a sense of how deep we go into some of the subjects. And of course, if there is something we don't cover today, please feel free to reach out afterwards, and we'll answer things in more detail. So it looks to be a bit of a mix, familiar to using it every day, and a few complete newbies to the Silfab side of things. So great. I will also probably turn my camera off just so that I don't steal any bandwidth unnecessarily, and I don't get distracted by my own face. So we'll start with kind of who is Silfab? Where has Silfab come from? Where are we going? Right, and this is kind of just a coverall slide here to explain the company history. So the lineage of Silfab companies started in 1981. The founders of Silfab Americas, which was in 2010, they'd been involved in PV supply chain and ingots, wafers, PV grid silicon, utility scale development, module development, cell development for 25, 30 years prior to funding and building out what is now Silfab Americas. As you can see on the map there, the top right-hand corner, the first facility that was built, the flagship facility, was built in 2010 for the purposes of a Canadian domestic market, but also to OEM for major tier ones all across North America. So during, between 2010 and 2015, if you used a module that was built in North America from a handful of other brands, I won't go into them here, chances are they were actually all built at Silfab facility. So we were, at the time, as this facility was being built out, there wasn't other module manufacturing expertise in North America. Therefore, we took a lot from automotive, and still some of the executive team and major engineering side of things comes from the automotive side. Coming from the high parts per million defect rates, low parts per million defect rates, the high levels of automation, the quality control, all of that stems from the functional background of the original development of the company, which was on the automotive side of things. So we built out that facility. It's on the west side of Toronto. I am sitting in it today. It still sits with 700-800 megawatts of capacity. Then in 2017, 2018, we took over a facility in Bellingham, Washington, up in the upper left-hand side. You can see there. We took over an existing facility, took out all the walls, doubled the capacity, and ran that 24/7 for the next handful of years, and then took over a facility in Burlington, about 40 minutes down the road from Bellingham, and have since actually amalgamated all of the manufacturing equipment from those two facilities in Burlington. So the company stemmed from international experience. The founders and still board members of the company are still very much involved in the international supply chain, but the company has since built out the entire infrastructure, the sales, service, support, the R&D teams, the sales teams, the manufacturing teams, the management, the finance, everything is 100% based here. All decisions are based here. And as you can see, building out from that infrastructure of the existing about 1.5 gigawatts, about 700 or 800 megawatts in the Toronto facility and 700 or 800 in Burlington. That big red dot on the bottom right there, that is the newest facility in Fort Mill, South Carolina. That is about 900,000 square feet. And that is designed first and foremost to get our domestic cell manufacturing up and running. So obviously with the IRA, we had always long had the business plan of further vertically integrating our supply chain and bringing stateside as much as we could. The IRA was kind of a happy circumstance that then allowed us to expedite the CapEx raise to build out that project. So that is a large building that is capable of holding upwards of 3 gigawatts of cells. We're going to start with 1 gig of cells and actually moving some module assembly capacity into that building as well, so that we can be building modules on both sides of the country and building cells. We will touch base more on that cell facility shortly. But what that kind of leaves us with, right, is a domestic company, 100% privately owned, 100% owned and operated, managed in North America, with about 1.5 gigawatts of module assembly operational today in 2 facilities, and starting to build out that third facility for the domestic cell side of things. So, to get this far, we are, a bit of a David versus Goliath story when we started, right? I mean, most of the module manufacturers in the industry are companies from Asia, Southeast Asia, Korea, etc., owned by other parental companies in other businesses. We have remained profitable for 15 years of module manufacturing. We have outlived everyone. We have built this entire empire that I just showed you, all on retained earnings and no debt in the company. And that comes from just making sound fiscal financial decisions, making sure that you don't build a warehouse full of product to turn around and have to dump it afterwards, right? Just in time manufacturing. It means having best in class technology so that you don't have higher RMA rates. Building that sound financial basis has allowed us to continue to grow year after year after year, improve our bankability. So we are on every major AVL, from every lease PPA loan provider. We are on every AVL in the industry with unlimited acceptance on those platforms because of that financial platform that we've built. We can't just fall into the same categories as large scale, low efficiency, low cost production, because that is a price play. And as you can imagine, being a domestic company with 1,000 employees that all have a living wage, etc., we cannot build modules at the same price as someone who is drawing equipment from China, building in Southeast Asia and shipping it over. So how do we differentiate? And a lot of this presentation is about that differentiation, is about that ability to create a different value stack, so that you, our partner, have something different to talk about at the dining room table of Jane and Joe American. So the R&D side of it is a big piece of it, right? We'll talk about the products in a couple slides here, but we are already 100% switched over to N-type, and we've already had a back contact product line for the last 4 or 5 years. So we do not build low efficiency, low quality products. We always want to be ahead of the curve and having a leading efficiency, better degradation rates, better temperature coefficients, etc., using higher quality products and better technologies so that we can offer you something different to talk about, instead of just saying, hey, we have a 400 watt panel along with everyone else. Isn't it great? You should buy it because it's really cheap. Our stance has always been to provide a better value stack in all ways, shapes, and forms, so that you have something better to talk about, and provide that better offering to the homeowner or the business owner. Being based here and developed here is given us obviously a leg up on the ethical supply chain side of things, because we've been importing product here. The company, the ethical background of the company has always been, being green, being ethical in green. So don't just be in the renewable industry, but then use, maybe employing some nefarious processes to lower your cost. Do it the right way. Do it with a clean and ethical supply chain that doesn't include forced labor. Make sure you pay a living wage to your employees. Make sure that your accounting is above board and obviously accounting to standard practices. All of those things have been a part of the DNA from day one. So as the U.S. administration and more policy gets involved in straightening out maybe some of the manufacturing processes of the solar industry, we're already in an absolutely amazing position, because that was part of our MO right from the get-go of the company. And then the manufacturing side of things, as I said, high levels of automation, first and foremost, from the automotive background. Robots don't take days off. Robots don't get stuck in snowstorms. Our levels of automation are incredible. You really don't see many people in the plants. Obviously, still have 1,000 employees scattered between these two plants, and hiring another 800 for the South Carolina plant. But it does require a good level of automation to make sure of two things. One, processes just continue to flow regardless of conditions of humans, and also the quality levels of automation is far better than having human interaction. The other side of it is just-in-time manufacturing, which is, don't build a ton of products, stay in a warehouse and wait for prices to fall and have to dump the product. We have always built the product that we need for our customers' demand. And if that slows down, that's fine. We need to slow down production. We need to, so that allows us to stay up to speed on technology. It allows us to stay up to date on recent cell pricing. And it means we don't end up with a big warehouse full of product that we have to dump at a loss and kind of upset the brand of what Silfab is. So that's been a big piece of our business, again, right from the get-go. So why domestic? Let's talk about this a little bit. There's a lot of reasons right now, right? There's obviously a new petition out last week, but there is 4, 5, 6 very obvious reasons why to support a domestic company and domestic manufacturing. Supply chain compliance, right? This comes down to a lot of the UFLPA piece. There were a lot of major tier ones that were locked out of the American market for year and a half plus while they attempted to prove that their supply chain was clean. Zero interruption on the Silfab side of things. We have always kept, we have audits done by PI Berlin and other independent engineers to continuously audit our supply chain so that our system is up to date and something we can brag about. The anti-circumvention piece, obviously the Oxen petition of 2 years ago that really took the wind out of the sails and really slowed down availability in the industry. The moratorium on those tariffs comes up in June, which is going to impact all of our lives. And now a new petition has obviously been tabled as of last week with tougher guidelines, more inclusive in its regions, etc. So again, unfortunately, for everyone on the call, we are going to go back into a stage of some politically based supply limitations, let's say. I don't think anyone understands the full extent of what that may be, but it's going to have an impact. If you've been in solar for longer than 6 months, these policies are what shape the supply and availability consistency in our industry. They have for the last 15 years. They will continue to. So that is going to have a major impact on the business moving forward. The one that is not specifically called out here, but the bifacial tariff, right? The bifacial tariff has allowed people to bring bifacial technologies without 201 and 301 tariffs, even though they might be using it on a flush mount black asphalt roof, which is a bit of a farce, not the intent of the exemption, but that's how it was used. So now everything comes in from Southeast Asia as bifacial so that you can avoid those tariffs. There is fairly widespread support that they believe that the Biden administration will remove that tariff exemption, again, adding to the cost of the modules that are coming from those Southeast Asian countries. The IRA, as I said, a happy kind of coincidence for us, as we already had this business model in the works. It obviously is built to favor domestic production, and not just domestic production, but domestic production by domestic companies. Right? The U.S. administration does not want these production tax credits, et cetera, to go to companies that are based offshore. You can't have American taxpayers' money going to companies that are based offshore outside of the United States, right? So having the companies being based here, and I think Silfab stands alone as a company that is based in domestically. Every other manufacturer who is here or is sending publications, news releases, press releases about building assembly here are all based in another country. So that will again become a part of the IRA rollout, is going to be who is actually even eligible for some of these production tax credits. The sustainability piece we'll touch on the next slide. But the final piece in the bottom right, it's let's call it a soft factor, but it's the warm and fuzzies of American made, right? When you're sitting down with Jane and John Smith, American homeowner or business owner, and you can give them the option of, this was made by a domestic company with domestic labor, and the supply chain was, is being built out in America. Is that not ultimately the choice that the average American makes versus this came from overseas, the company is based in another country, and we're not totally sure of the supply chain. As far as close rates, right, with your sales teams, that's a very big part of sitting down with the homeowner, the business owner, and talking through, what they would like to choose on their solar system. And we touched on this and just kind of a broader subject on the ESG side of things. Major institutional money is flowing into solar. We're not the Birkenstocks and ponytail solar industry that we were 15, 20 years ago. No offense to anyone with a ponytail or Birkenstocks. It is now being invested in heavily by major institutional money, and they are driving towards having this ESG compliance, having net zero targets. That businesses are looking to green their business and ready to invest financially into companies, industries that support that renewable side of things. So having access to recycling campaigns, having access to environmental standards, or being surrounded by what we believe to be standard environmental conditions in North America is not the same environmental expectations that are a manufacturing facility over in Southeast Asia. The social structure, having living wage, living salary for 1,000 people that can raise families, own homes and put their kids through school, the good governance side of things, of being audited by North American auditing accountant firms, so that everything is above board. There's no government involvements and subsidies. We are a privately held company, just trying to make the world a greener place, and hoping to continue to grow in coming years. So the ESG side of thing, being green in green, has been a statement at Silfab from day one, and that's allowed us to excel in this category ahead of many of our competitors. And the final slide before we jump over to a poll and talk about the product roadmap and some more technical specs really is, so this is the facility in Fort Mill, North Carolina. No artist's rendition or anything fancy that you're seeing on some press releases from some other companies. This is an existing facility that we have taken possession of almost a year ago. It has the requisite 17 gigs of power, millions of gallons of water, the gas infrastructure. It is just on the southern side of Charlotte, South Carolina, but it goes over the border, South Carolina, North Carolina. For the labor force, this facility is under construction today. Parts of the cell manufacturing line are starting to land. And the plan is to have that first gig of cell manufacturing equipment up and operational and running the first cells by end of year. So the stage that we're at, this is not just a press release. There is, we have placed all the POs. We have all the permits in place. These are publicly accessible permit information. You can search, and I encourage you, if you need to fact check some of the other announcements that have been made about manufacturing, check if they've got permits, check if they've got water contracts and gas contracts, check if they have the pieces in place, because this is 6 to 12 months worth of work to get these things in place. So you build a manufacturing line in the manufacturer's facility, you get it operational up to 80-90% efficiency, then it is wrapped up, shipped to its location, and then rebuilt again to run, so that you're not ironing out any of the kinks in your manufacturing facility. It is done in the manufacturer's manufacturing facility. So that line is operational. It will be shortly packed, strapped, wrapped, and shipped to this facility and be built out to be starting to run by end of year. This facility is, as I said, 900,000 square feet, so it is actually big enough to hold about 3 gigs of cell manufacturing, or 1 gig of cell and 1.2 gigs of assembly capacity. So we are still working on kind of the final build out. Once we get this line running, we will build out the remainder in 2025 of the selection, and we're kind of working on that final mix of how much cell versus module assembly. And that type of facility requires 800 new high-paying American jobs. And that is a big piece, obviously, of the IRA. What it is meant to incentivize is not some financial accounting game of playing with the numerator and the denominator to try to get yourself your domestic content, but it's building American jobs. And so that has been our drive right from the get-go, is to bring stateside as much of the domestic supply chain as we possibly can to build our modules. So we're going to go to the second poll here. If Rachel could help me out, just trying to think of your typical customer that you speak with. What is the most important thing when you talk to a homeowner or business owner about getting solar? What are their questions? What dominates the conversation? And this helps us, cater to the needs in the industry, and ultimately what our value stack should depend on, what we should build out most, right? So I'm saying, obviously, price rise up pretty quickly. That's might not have been the top, usually the top answer, but maybe not so dominantly until interest rates rose and made the cost of solar considerably higher. Technology coming in second, certainly here, with people want to make sure that they're putting the right thing. This is probably probably the second largest investment a lot of homeowners will make over top behind their homes. And so putting the right technology with the right warranty and with the right company, installer warranty, etc., is obviously an important aspect of that. So thank you for your answers, everyone. So let's jump into the product roadmap. We like to break things down into 3 categories. It keeps it easy kind of on the marketing side. It keeps it more centered for our product R&D teams, and it limits the number of SKUs we have for you to choose from. And that's ideal for a few reasons, right? So Silfab Prime is kind of like the run rate, the 80% of our residential production volume. We have 4 lines that run it in the United States. So large volumes of prime. Prime is now the NTC, so it is an N-type cell that we have switched to as of Q1 of this year. Silfab Elite. So let's think of the good, better, best, right? Is a pretty common analogy. We don't have a good. We don't have a low cost, low efficiency, mass built in Southeast Asia, generic product. That's just never been our business model, and it never will be. That has not been a part of our DNA. For us, of the good, better, best, we like to have a better and a best, so that your sales teams and the average American homeowners and business owners have a bit of an option as to what they want to put in part of their array. Silfab Prime being kind of the good, better, best, being the better. And then Silfab Elite is a back contact technology, higher efficiency, better aesthetics, better operational characteristics, etc. So we are the only ones building a back contact technology in the Americas today. It is called metal wrap through, so it has a conductive backsheet built into it, a layer of copper in the backsheet, and we will get into both of these technologies a little bit more after these slides. And then Silfab Commercial. Silfab Commercial has historically had just one module. I will show you now has two, so it's maybe morphed into Silfab Commercial / Utility. And you can see the obvious changes. It is bigger. It is a silver frame. It is a white backsheet. At the end of the day, it is backed by all of the same quality, the same N-type cells, the same 25-year product warranty and 30-year performance warranty, all of the same bells and whistles you get with partnering with Silfab, but we extend those to our commercial and utility lines, so that whether it's you're a residential installer who does 2 megs of commercial a year, or whether you're someone who does 150 megs of rooftop, carport, and community solar, you can partner with a domestic company, speak to 100% of the company, all decisions being made here. That's important for your team to make those decisions, right? And so the other commonalities between these, before I break off into kind of the differences, is they are all put through a high level of testing. They are all 10-watt power classes. They are all backed by the same 25-year product warranty, 30-year performance warranty, etc. Right? So, talking about that, there's a handful of nationally accredited testing laboratories. PVEL being kind of the largest and most well-renowned in the Americas, Evolution Laboratories. So it's one thing to go through all the testing yourself and choosing superior materials, choosing superior technologies, working out the right recipe on all the manufacturing equipment and getting the operational efficiencies. But it's another thing to then hand that to a third party and have them beat the living crap out of your panels, right? So here's a handful of those kind of 5-6 major categories that they then go and test for. And these are kind of advanced life cycle testing, right? So you take a panel and you simulate 20-25 years worth of environmental conditions, hot, cold, thermal, photo-induced degradation, loading, dynamic loading, right? Take a heavy weight, put it on a module, pull it off, put it on, put it off, pull it off, so that you're getting all of these simulated conditions. And what they do is what's called, PVEL does top performers. And so we put all of our modules into the PVEL testing every year, and we come out with the top performer, and not just top performer in one category. You'll see someone advertise that they're top performer. You dig a bit more into it, and they got it for thermal cycling. We get the top performer in all of the categories, right? So we make sure that the product that we build here, designed by our team that are based in both Toronto and Washington, it's built to stand the test of time, and that we live up to and above our international competitors. Right? So let's look at Prime. So this is the product that is running in 2 plants today, and will be running in the South Carolina plant by end of year. So 420 QD. So the 420 is obviously the wattage. Those 2 letters, Q and D, represent the technology and the footprint of the module. So Q is the technology. So that is a monofacial N-type module, hence the Q, or that's our designation for Q, and D is the footprint size. So you'll notice if you've used our 410 HC+, that was our prime category in 2023, that was a 20.7% module. So PERC really kind of has plateaued on its efficiencies, right? P-type PERC has been kind of the leading efficiency for the last 8, 10, 12 years, P-type, and then PERC is going to take it over for some other P-types. It's really reached its efficiency caps. And so as much as you can do to that technology, we're not going to recognize 21, 21.5, 22% efficient modules. Jumping to, so this is our first generation, first bin class of this N-type module, and it already flashes at 21.5% efficiency at positive tolerance, and we will be running a 430 on this product in the Q3 timeframe, taking it to 22%. So that is a huge jump in efficiency. This is, I want everyone to understand, this is the single largest jump in cell technologies in the last 10 or 15 years. There's some other smaller kind of niche technologies that you'll see in the market. LG used some IBC. There's a bit of heterojunction. Those are very, very small supply chains globally, hence a slightly higher cost to build them. And they're still relatively small volumes of deployment. The entire global supply chain of PERC is being migrated over to this N-type cell because it can be made at approximately the same cost, but the benefits are massive. They far outweigh what PERC can do, and the efficiencies are a quick jump right off the bat. Something else you'll notice on here is that this moves from our M6 cells with the previous product to M10. If you don't know what that means, it's a larger cell, and it means that the physical dimensions are about 7 inches shorter than the previous Prime product and about 4 inches wider. This cell size is what the global PV supply chain seems to be standardizing on, luckily for all of us. We may get to actually standardize on a footprint of module for the next couple of years. Would be great after swinging through all of the different cell sizes that we've been that have been available globally in the last 5 years. The other big piece on this one is degradation warranty. So this jumps huge in efficiency and also goes from a 0.5, 0.6% degradation down to 0.3%. So now this is our standard run rate, high volume. This is our better module, and it has a 0.3% degradation, 21.5% efficiency. That is the technical specs of any premium module you'll see in the market, and this is our standard run rate, or our run rate middle class. Silfab Elite 420BG, and of course, when our product team is tasked with developing a product, wattage is not what they think of when they think of premium, right? Everyone can go and build a bigger module. That doesn't take a genius to do that. Just make the module bigger, add more cells, get a bigger piece of glass, and you're off to the races with higher wattage. That does not make it premium. So our team concentrates on the equipment that they use, the technology that they deploy, the techniques that they use within the manufacturing facilities to try to get the most premium module they can without just relying upon a bigger module, right? So this is being built in the Burlington facility today. It's already running at 22% efficiency. This still, again, has the 25-year product and 30-year performance at 0.3%. You can see the aesthetics are wildly different than anything else you will see. I think this is the best looking panel in solar. I've got a picture of it on a roof and a few slides. You'll notice it looks amazing. It's the only back contact in the industry, and it looks kind of just like a flat screen TV turned off, right? So just a matte black color from a distance. You'll see a faint star pattern. I'll explain that in a second. This module, you'll notice, is staying M6 wafer size, cell size. So it will remain at 40.5 inches wide. So the Prime product has gone to 44.5 inches. This product will remain a bit narrower at 40.5 inches. And it's because it's a full cell, it has a single junction box. So there are some considerable differences, and we will highlight those in upcoming slides as well, between Silfab Prime and Silfab Elite, even though the wattage is the same today. Silfab Commercial NTC. So we are running out the last little bits of a 500, which is a P-type cell, and we will be swapping an N-type cell next month. That, again, does that same huge leap forward but in the commercial side of things. So now we've got a 22% efficient commercial module with a 25-year product warranty and a 30-year performance warranty at 0.3% degradation and amazing temperature coefficients of an N-type cell. When you're penciling out a commercial project, a lot of the time it's looking at the LCOE, so looking at how much power is being produced over the lifetime of the project versus what the cost is to build the project. So having a module that's much higher power density, so you can fit more into the array. Having a module with the degradation rates that are half of what the prevailing commercial products are, and that better temperature coefficients, I think you're going to find, 20, 25-year production modeling, that the LCOE is far better because of the operational specs of an N-type product versus a P-type PERC product. The other thing to consider on this is the footprint size. A lot of manufacturers have kind of, they were at a 485 to a 500 to a 520, and they're jumping to this 580, 590, or 650s. Those are very large modules. They have a place in utility, there is no doubt. But when you're thinking about the logistics of moving around a module, when you're thinking about a commercial rooftop with HVAC and parapet walls and all the things you've got to fit these things into, when you're thinking about upload, wind lift ratings on carports, etc., having a massive sheet of plywood-sized module becomes a bit of an issue. So this is our solution to that, which is a high density, 520 watt module that we will build for the rest of this year, so that this is applicable for those rooftop, those carports, small ground mounts, something that's manageable, that you can move around and fit in tight spaces. You'll see that it's 520 QM and XM. So this will actually run as a monofacial product for the first few months, and then we'll migrate to a bifacial module by the end of Q3 time frame. So all generally the same specs, same footprint size, same dimension, same warranty, but it will be a bifacial product by the end of Q3. Again, all made in the US. This is made in our Burlington, Washington facility today. So it is BAA compliant. And then, of course, when we are building domestic cells into that South Carolina facility, those will be slid into this module and the next one on the next slide for IRA domestic content, for the extra 10% IRA adder, right? So speaking of the next module, the 570 XM. So nothing crazy different between these two modules. You'll notice the dimension is still 44.5 inches wide. It is one extra row of cells longer. So this one being designed, this will start end of Q3 as a bifacial product, and being designed for very large rooftop, right? You're a big Home Depot, IKEA, Walmart, and there's no obstruction, and you've got a massive open location to build a megawatt. Maybe this does come into play. But a lot of times this will be for ground mount, community solar gardens, etc., when you're throwing on ground mount racking, and you can use a slightly bigger module. So again, very differentiated in the industry. This will have a 25-year product and a 30-year performance warranty at 0.3%. So again, I encourage those that are involved in the commercial and utility side of things to grab the PAN file for this and model this out and actually see the differences in production that an N-type cell will make over the duration of a project. So a few examples of the commercial side of things. We've been involved in commercial for our entire 15 years. We've obviously done a lot of residential. We've always been kind of 20-30% on the commercial and small ground mount utility side of things. And the IRA and our kind of leading the charge to that domestic cell production has kind of accelerated the demand on the commercial and utility side of things. So our business is migrating quite quickly to a lot of these larger modules, and that's what some of the facilities are being built out to handle is these larger module form factors. So now let's get into a little bit of the technology side of things. We're at 40 minutes. We'll get through this and hopefully have some time for questions. So the elite technology, let's jump into what makes it different. You think about a conventional module, you lay a piece of glass, a piece of EVA, then you solder together cells, you lay those down, then an EVA layer and a backsheet, and you laminate that. And so you're creating an electrical circuit on the front of the cell, the polysilicon that you're using in that module. Think of elite, the back contact side of things as being kind of a reverse. So you're actually laying down a conductive backsheet. You see the very bottom layer is that light brown copper color. That is a monolithic backsheet. So it is a sheet of copper, very thin copper, that is the conductive circuit, so that there's nothing going to be on top of the cell, right? You've got this backsheet with an embedded layer of copper. Then the layer over top of that is an insulator layer. It does two things. One, it adds to the rigidity of the module, and I'll show you an image of some kind of extreme loading testing. And then secondly, you can see that it's a bunch of circles or little holes. Those allow the connection between the back contact of the cell and the appropriate location on that conductive backsheet, right? You can't just lay a semiconductor or cell right on top of a conductive material like copper. You need to have an insulation layer. So that insulation layer isolates that contact point and also adds rigidity to the module. Then you've got a layer of EVA kind of thin there, and then you've got your glass. And we actually even employ a different type of glass with dual AR coating, anti-reflective coating, so that we can get the best performance out of that module as possible. And so the next couple of slides will illustrate really, what we go through to make a premium product, right? So starting from the glass, right off the bat, you can kind of see that green line as far as the percentage of light capture based on incident light angles, right? So conventional glass reflects, right? Then you get into a textured AR coated glass, which is what we would use on our prime product, and it gets a little bit better. You can actually buy a much higher end glass with dual AR coatings so that you are making sure you absolutely capture as much of that incident light angle. So early mornings, late afternoons, evenings, and also when you've got diffuse light coming through cloud cover, that you're able to capture as much of that light as possible at the glass level. You don't want to lose it right off the bat by having it reflect off of that glass. So right off the bat from the get-go is choose high quality and superior products or raw materials to be used within that technology. Now let's move a layer down and start looking at the resistance in the circuit. So two major aspects of it, right? Polysilicon, or your cell, is the most expensive component of your module and the most important. And by running a front contact module, you're running a bunch of strings, conductive fingers across the front of them, which if light hits those, it actually reflects off, right? And you lose that incoming light. And so by eliminating that from the front of the cell, you actually get a better overall absorption of incoming light because you don't have anything creating shade, right? Effectively, those contacts along the front are actually creating shade on that cell. And the other aspect of it is the resistance in the circuit, right? Those creating that soldered circuit on the front, there's a resistance in that circuit. The conductive backsheet has a much lower resistance to it, and therefore you see at different irradiance levels what efficiencies we can recognize versus a conventional module. And again, the conventional is nothing crazy. That's our prime module. That is our front contact, was PERC, now N-type module. That's when you get into those lower irradiance levels, your efficiency levels die off pretty quickly because of these factors. Having a proprietary back contact cell, the premium, the circuit on the back of the cell has this impact of being able to yield a higher efficiency of conversion of that light. Moving even further down into that copper backsheet side of things, the backsheet is obviously the way that the power migrates from the cell to the junction box. But the second thing that it does is actually acts as a heat sink. So that same module sitting in the exact same conditions in Los Angeles is actually going to operate 3 to 4 degrees cooler than a conventional black backsheeted module with a front contact, because that copper layer is acting as a heat sink and dissipating heat off of the module. And there's obviously an inverse relationship between temperature. The hotter a cell gets, the less efficient it is. Therefore, if we can cause those cells to operate at a lower temperature, we can maintain a higher overall efficiency of that module. Right? And then, choose better products, choose better technologies, employ high levels of quality and ingenuity in the facilities, and then beat the living crap out of it. So there's over a ton of sandbags onto an elite module, and then you pull it back off and you run it through electroluminescence again. You run it through the flash test. You look to see that you've built a module that's very rugged, that can withstand all of the environmental conditions that Mother Nature throws at it. And of course, a bit of a duplicate here, but then run it back through a third party to have all of that same stuff done. Submersion testing, thermal testing, mechanical stress testing, all of that type of stuff, so that we make sure that we are building the best possible module that we can. My last piece on the Elite is, a premium module should have a premium appearance, right? So here's a Elite installation, matte black, looks amazing, best looking panel in solar. And my other part of this is if a homeowner is gonna invest in a premium product and put the best stuff on their roof, they should be investing in something that's made in America, right? All the other premium products that are on the market today are made offshore. Here is the one and only premium module in the market that is actually built by American labor, built here and shipped here and used here. So a lot of good reasons to use that Elite as your kind of premium offering. If you have the good, better, best, this is our best category. NTC, I'll try to get through this in 2 or 3 minutes here, and hopefully then we can talk to some questions. So our N-type cell, so this is the same cell employed in both the residential prime and our CNI. And here's a lot of people ask the question of, okay, so what makes N-type any different than P-type? Why is it so much better? So here's kind of an artist rendition, or the best way that we could come up with graphically or illustrating kind of what the difference is. So on the left is a positively charged cell doped with boron, and very conventional, very standard for the last 10, 15 years. There's what's called a passivization layer. And so when a photon of light comes in, a charge carrier, right, there's within the cell, it absorbs that light. It needs to go through a passivization layer to be able to be then conveyed to the output point, or the junction box. With a P-type cell, there's actually physical holes that those charge carriers need to go through. And so you think of a traffic jam on a highway. You've got a highway with 2 lanes, and you've got a lineup of traffic. Those cars are kind of like charge carriers. They've absorbed some incoming radiance from the sun, and they're trying to get to the contact point so that they can then run out of the cell to the junction box and be recognized as power. But they have to line up because there's physical holes for those charge carriers to go through. A huge difference to what the N-type cell recognizes is this passivization layer is actually really more of a diffusion. So there is no limitation to the number of charge carriers that can go through that passivization layer and reach those contacts to then be carried off to the junction box of the module. There's no limitation there. So there's the big difference between the module we were building with P-type 3 months ago. After 8 years of innovation, we got to 20.7% module efficiency. And the first N-type cell we make right off the bat is 21.5 and moving to 22% in Q3. That is the best way that we could come up to explain the difference of why these technologies one is so superior to the other. So what does that mean? Well, higher power density, right? So you get to use less modules on the roof or on the CNI facility, whatever it is. You get to either recognize the same total nameplate with less modules, i.e. less EBOS, less microinverters, less racking, whatever that is, or you can squeeze, if offset is the name of the game, then you can squeeze in more power on that rooftop so that you can get a bigger nameplate on that system, right? It's important. You roll trucks, whether you put 6 kilowatts on a system or whether you put 7 kilowatts on that roof, your truck roll costs, your permitting costs, your design costs are all the exact same. So if you can get that much more power in the same price for the panel, if you can get that much more power, then you're utilizing that truck roll cost, et cetera, in a much better way, right? Another big part of this is that degradation rate, right? So the average degradation rate in the market might be 0.55, 0.6, somewhere around there today for PERC. At 0.3%, that's an extra 7% of power by year 25. So that's 91% of nameplate after 25 years. We have a 30-year warranty, which is, again, differentiated for most in the industry. But because most have a 25, we also list that 25-year number so that everyone kind of recognizes the difference between this warranty and someone else's. So that is a huge difference over time of how much power is going to be produced, simply because those cells will not degrade as quickly as a P-type PERC cell. And the last major difference is temperature coefficients, right? So again, this inverse relationship where when a cell gets hotter, and if you can think of a hotter place in your house than up on a black asphalt roof in the middle of summer, they get less efficient and they produce less power. So by having better temperature coefficients, you're adding up to 2.3% more power in that same system when those cells get hot. So is it going to buy you a new Ferrari in day one? No, of course not. But again, you model out that different temperature coefficient, even keep the efficiency, keep the degradation the same, and model that out with different temperature coefficients. You're going to see a return of hundreds and hundreds of dollars over the lifetime of the system. All right. And my last poll. And at the end of the day, if you answer B, then I'm going to simply tell you, please reach out to me, r.adams@silfabsolar.com, or any of the the various regional sales managers at Silfab, if you have contacts with them, to ask those questions, dig in a bit more about certain topics that I didn't cover adequately or that you need more details on, and we will address them from there. So from there, I will go to the chat side of things, where I see a handful of how far do I need to go up. Uh-oh. I'm trying to look for the first. I think David might be the first question up here. I don't know if I'll get through all of these, but if I don't get through yours, then reach out to me and ask it after the hour is up here. Will you be able to price match with imports? Generally, no. Right? You're using an unknown supply chain. You're using Southeast Asian labor, Southeast Asian insurance, Southeast Asian energy rates, Southeast Asian lack of environmental protocol. Generally, no. We are going to be very competitive with anyone building here. We're going to be within striking distance of stuff built overseas. The benefits are coming in, obviously, the stability, the ethical aspect of the supply chain, the IRA incentives, et cetera, et cetera. We can be pretty damn close. But no, generally, if you're going to build it in Southeast Asia, you're probably going to build it at a lower cost than we can. Ohio, Redding, California, Bloomington. Oh, geez, David, you got a big note in here. I don't think that's a question, so that's for people to read. Can you expand on what you mean by politically motivated supply chain limitations? UFLPA, anti-circ, etc. Right? Our supply chain team is actually one of the biggest in our company, simply because we need to have multiple sources of our raw materials, components at all times. We have a handful of different products that we have different cells for, etc. And being ethical, being green has always been a major mantra at Silfab. And we've been importing products here for 15 years. Others are just starting now to either bring finished goods or have to bring raw materials like cells, wafers, etc. into the country. They're learning very quickly that the U.S. administration is very interested in controlling how much foreign supply chain comes into the country. That has, unfortunate maybe UFLPA, forced labor type of implications, etc. So we stand in a great position because that has been an overarching, ideology, philosophy in the company from the get-go. So as the U.S. administration gets stricter and stricter on it, perfect. It's holding others to the level of accountability that we've always held ourselves to. Climate change. 10% is only for commercial install, correct? Jacob, somewhat incorrect. Third-party owned residential. So that is considered a commercial transaction, right? So Sonova, Sunrun, LightReach, Positgen, you name the lease PPA providers, that is considered a commercial transaction. Therefore, they would be eligible for the extra 10% ITC if they were to satisfy the 40% domestic content of the project. When will the IRA 10% ITC add-in be available to be taken by Silfab clients? Very good question. There are many schools of thought. We can build a mid 20% domestic content module today. Some are believing that you can use some domestic racking, some domestic EBOS, a 25% domestic module, and you can achieve that 40%, and therefore achieve that today. We are still at the beginning of the tax year, so I'm not sure anyone has proven that yet. But there is a school of thought that says you can combine different domestic contents from your various components, and therefore we could help. The thing is, you gotta think of a component as not being compliant, but in adding to the domestic content of the project. So when we are using our domestic cells and some other domestic supply chain next year, our module, unless you're using a very expensive inverter or something else, our module on its own would likely achieve the 40% domestic content of the project. You need to achieve 40% domestic content, not of labor, but of raw materials, to achieve that 10% ITC. So having a very high efficiency, or sort of high domestic content percentage on the most expensive component, i.e. the module, gets you there the quickest. That makes sense. Someone's talking about WD-40. They're lubing things up. Silfab have plans for in-house module recycling at end of life. Not today in-house. What we have recycling partnerships with two different groups because we have, you ultimately get out of spec feedstock, right? Like a cell, a frame, a piece of glass that comes and it doesn't meet your spec and you need to recycle it. So we already have recycling agreements with two large recycling groups across the United States, and we continue to use them for that manner. What we've been working with SIA and WASI in Washington and all sorts of different groups is what happens at the end of life side of things, right? That is still being determined. Ultimately, Silfab is not the best setup to recycle solar panels. We build solar panels. Can we be a part of the solution of creating a distributed program to recycle those end of life through our existing recycling partnerships? Absolutely. And so that's kind of what we're a part of. Do your modules meet IRA requirements for domestic content, all assembly components made in the US, subcomponents, etc.? So I think I answered most of that. Today, no. We have historically been sourcing. There is no domestic supply chain. There is no one building cells in America today. First Solar would be the exception, I guess. They make thin film in the Midwest. Can't use it on residential or any dwellings. But no one makes polysilicon cells today. There is no glass production today. There is a very, very small amounts of frame, EVA, and backsheet, and we can supply that for specific needs to meet, as I said, kind of a 20-some-odd% domestic content. Can be achieved when needed. To get it way up into the 70% range is the cell, right? The cell is 40 to 50% of your entire cost basis as a module provider. Is Tigo Smart Module Junction Box still an option? No, we have not partnered with Tigo in 6-7 years. Got a bifacial commercial panel. Nick, yes, both of our panels commercially will be, one is bifacial from the outset in September, the other one will be mono until September and then bifacial. So yes, both will be as of September, the 520 and the 570. How resistant to hail damage are Silfab panels? Competing brands. Everyone has to do their UL certification, which requires 1-inch hail from what distance? A foot. 1-inch hail at 25 meters per second. I might be making up some of those values. We are tested to all of those and then go above and beyond in our internal testing. But there is no official certification for hire. You can test internally to your own hire, but ultimately everyone certifies to the 1-inch, I believe it's at 25 meters per second speed. So we are certified to the requirement of UL requirement, and then we do all of our own internal testing to make sure that it's robust beyond that. We do have the prime product, the 410HC Plus, that's been available for the last over a while, it has had the highest uplift rating. It's one of, I think, 3 panels that's certified in Miami-Dade County in Florida, which have very, very extreme uplift ratings. Hurricanes cause low pressure zones that pull upwards, and therefore the uplift needs to be considerable, and we build big, bulky modules to achieve that. Where did I get to? Are these perquisite? No. Oh, I got something else popping up. Standard physical dimensions. Systems. Sorry, I'm just reading this question quickly. It's all about module sizes and standardization, which is a great question, Alex. The entire solar industry has been really kind of at the whim of the available ingot wafer supply chain. So when a multi gigawatt ingot and wafer and cell supplier goes from M3 to M6 as a module, excuse me, as a module manufacturer, you're kind of forced to go in that direction as your supply chain dries up. And so that's what really has forced the changes in sizes. And so believe me, it's frustrating for us. When we change cell sizes, it often requires upgrade of the front end, which is millions of dollars. It requires the upgrading of a back end, laminators and framers, because they can't handle larger frame sizes, which is millions of dollars. This costs us over the last 5 years tens of millions of dollars in upgrades to adjust to these cell sizes. So it's a pain for all of us. The M10 does seem to be a standardization point. So 44.5 inches wide, and then Resi would be one length, CNI would be another length, a bit longer, utility would be a bit longer from there. But that M10 wafer size seems to be kind of a standardization point in the industry. So hopefully that our new home developing partners, they love that we're already onto the M10 wafer size and an N-type cell, because they know that that's something that's going to be pretty standard in the market for the next 2, 3, 4, 5 years, hopefully. State of Ohio is building a 30-acre farm field down the road from me. I don't think that's a question. Data sheet on the 570. Was that not in the handouts? Okay, okay. I will send the 570 data sheet to Rachel, and hopefully she can send that out to others. Recommended tracking equipment for 100 megawatt utility. Michael, why don't you reach out and you can discuss with some of our product team on that one. It comes down to IRA compliance. Is steel, structural steel, included in in the IRA, domestic content, and there's a kind of a few different things to think about there. What about the buy-side solar panels? I think I answered that. Yes, residential is monofacial, but both our commercial and utility will be bifacial. Presentation will be provided. Yes, the link. Can homeowners take 40% ITC now? No. And likely the homeowner never will. That's something important to understand. The ITC and the Resi side of things is for third-party owned residential systems, as it's written today. How does Prime compare to Elite? Prime, our new Prime doesn't really even compete to the typical average. I mean, the average module that's been out there has been 400, 405, 410 PERC. So our Prime now really kind of is all of the values of a very premium module, but it's our kind of standard. We've already had the Elite has always been our premium module, and it's the Prime has certainly caught up to our Elite product pretty quickly, but there's still the aesthetics, the efficiencies, and the temperatures by operating cooler because of that heat sink. Those are three still pretty big differences on that Elite module. Do you export? I'm not sure where that would be, so maybe reach out. Depends where. We ship all over, Canada to Panama, but limited export beyond that to date. Thomas answered to Nick that domestic content is only commercial. Be very careful. A third-party owned residential is considered commercial. Is there a model 100% US made apart from raw materials? It will 100% US made module will not happen for some time. Glass is kind of one of the big ones. There is no commercially available large volume of floating tempered PV glass available in the market today, and those are big facilities. There are some that are planning to build them, but it will take a few more years. So you can get EVA, backsheet, frames. We'll be building cells, but there are a few components that will still be tough, and glass being one of the biggest one. Where are we? Source, thanks the time, guys. Nick, second commercial. It's all right. Trying to find which ones are questions. Rebate commercial panels. Great job. I think I've got to the end of the questions. Oh, no question. When will we be able to purchase 520 ITC compliant modules? We will be we'll be running cells by the end of this year. So it will be 2025 before the 520 is widely available in CED Green Tech websites. Not websites, warehouses. Started with a W. Can customers tour your plants? Yes, we love having people through. Yeah, reach out. Love it. Do tours all the time. It's so validating to have people there looking at the levels of automation and quality control and saying, like, I stood there and watched our panels being produced. And that's why I choose Silfab, because I met the company, I met the guys running the lines, and yeah, so anytime. Let's see, just give me the 410 Elite is no longer being built. Yes, we have cell efficiencies that get us all 420s today. And someone making a hockey puck joke, which I like. Gail Burrington, great comment on copper. Yes, copper is very expensive, hence why the Elite product costs us more to make. Trying to get it done with an aluminum backsheet. The issue is resistance levels in aluminum is higher than copper. Therefore, you'd have to have a thicker layer of aluminum. So there are some hurdles, obstacles, but that is actively being tested in laboratories today, is getting away from copper and getting to an aluminum backsheet to bring the cost of that backsheet down so that we get all the bells and whistles without the premium price tag, which is obviously the ultimate goal here, right? What percentage of PV system is typically made up of panels? It's almost impossible to answer. It depends. It depends what inverter you're using, depends what racking you're using, depends what, is it a ground mount? Is it a pole mount? Is it a rooftop? Is it, panels make up a large chunk of it, certainly can be upwards of 30, 40, 50% of a system cost, but it kind of depends whether it's resi, commercial, or utility. It depends what type of inverter you're using. That's a tough one to ask or answer. Do the 400 HC mods qualify as domestic content? No. So again, the 400s, 410s, and even the 420s we build today have limited amounts of domestic materials in them. They are BAA compliant, so they can be used on military installations, they can be used on VA hospitals, they can be used on government buildings, etc. But the IRA and BAA is different. So we are building out the necessary infrastructure to produce cells here to get that, which is our major BOM cost, right? Building out that so that we can build as high of a domestic content module as possible. Someone's throwing very specific EPA tax deduction. I will go ahead and state that I may be able to sell panels, but I am certainly no accountant, tax lawyer, or employed by the IRS. So, who owns Silfab? We are privately held by, I own part of Silfab. Many of us do, all the employees of the company, because of our involvement in the company. We did take an equity from a private equity firm called ARC Financial. They invested a couple $100 million over the last couple of years. They represent funds like the Yale Pension Fund, the Canadian Teachers Federation Pension Fund, Ontario Power Generation. A lot of academic institutions actually invested into that fund. So we are a North American owned organization by individuals within the company and the ARC Financial equity raise. Data sheets, email, and recording. Yes, data sheets. We'll send out all the data sheets including the 570. Yes, presentation will be employed. Employer lost a lot of hail damage past years. I asked utility interest in resiliency and structure. Something to be said about that. So because we build all our modules here, have always built our modules here, we keep an inventory of every single module we've ever built. So very different than having something built in Vietnam. They ship over full containers, they sell full containers, and then when you have an issue with hail, you have an issue with, something broke a panel, whatever it happens to be, you cannot get that size of module again because it was built overseas and they do not keep an inventory. We have RMA inventories of every single module we have ever built for the last 15 years. So if you have a warrantable condition with a Silfab panel, we can replace it like with a 3 bus bar poly cell from 8 years ago. And we have those in stock to supply. These are little things that people don't think about, but that's a big difference when you've got a system that's 10 years old and you need to replace one module. We keep an RMA inventory for those reasons. Any talking going public? Our ability to raise the amounts of money that we require will likely exceed the private markets at some point. When you're raising hundreds of millions at a time, private placements become difficult. Public markets are a little bit easier. But at this point in time, we like being independent, and we like making our own decisions, and we like being nimble and versatile and adapting to what our partners need, and changing the direction of the ship as quickly as we need to. And that is a huge benefit of a private company. I've gone public with other companies, and you lose that very quickly. Time frame, Silfab domestic. We will be building domestic cells by end of year, so 2025. Export to the Middle East. Depends. I don't see a reason why not. Based certification and freight, etc. Reach out to me and we can have that discussion. We mentioned so someone's asked about wafers. We have multiple wafer providers. It is your death wish to be sole sourced by any given particular BOM, glass, frames, EVA, anything. In an industry like this, you want to have 2, 3, 4 sometimes tested, certified, vetted suppliers with clean, ethical supply chains, et cetera, so that when there is supply issues, you don't miss a beat, right? So yes, I signed the agreement with Norsun to continue to control even further downstream our sources of poly and add to the empire. Awesome. RMA, the labor cost warranty. Oh, a labor cost warranty from Paul. I don't think it's necessary, and it shouldn't be a major talking point. I know it's a sales pitch, but how many panels do you ever go back and replace? So it comes up. I think we put our emphasis on building modules that don't get returned instead of talking with our lawyers and our banks as to what accruals we need to keep to offer a labor warranty. So we have considered it a few times, talked about it. At this point in time, we are concentrating on having the lowest parts per million defect rates we can, so that no one needs to go back and replace those modules. Those that I've spoken to as well that do have labor warranties, I like asking, have you ever actually claimed it? And they all go sheepish and say, no, because sometimes it's actually just more paperwork and pain to try to file something and to get a couple $100. So we have thought about it, yes. At this point in time, we are concentrating on other aspects of our business. When sun's at 90 degrees to the panel, what's the max 420 panel would produce? Oh man, I have no idea, Jason. At 90 degrees to the panel, you would have very little. I could not answer that question, Jason. Can I share my content? Let me type my... make sure I did that correct. There's my email address at the bottom of the chat. Hopefully I've answered all your questions. I appreciate that 92 of you have even stuck around 14 minutes past. I very much appreciate the time. Hopefully I've answered your questions. If not, please do reach out, fire me an email. We'll get someone on it and get your questions answered. Hope everyone has a good Thursday and leading into a weekend. Enjoy. Thanks all.
Thanks, Ryan. That was awesome. You answered those questions heroically. Thanks,
Appreciate
everybody.
everyone's time. Thanks, guys.